Okay, welcome back. Hope everyone is staying safe and doing well. So let's see where we're at on the syllabus here. So we've got so I extended the deadline for the first week's homework assignments, right? So for the chapter 1 and chapter 2 homeworks. And so all the homeworks that have been assigned are due today. I think and most of you have most students have turned those in. Yeah, so the chapter 1, chapter 2, and chapter 3 homeworks, assignments, those are due today, or tonight, I guess. And so if you haven't got those in, please do, or let me know if you have any problems with those. But most students have done that, but yeah, the first 3 homeworks are due today. And the material we're going to do today is for chapter 4. Which is on elasticity. And so I think everyone's good on the first 3 homework assignments. Any questions on the past material before we do chapter 4 for today? Okay, so today we're going to do chapter 4, which is on elasticity. So this is you've probably heard of this concept in economics, but it's pretty important. And it's one of the key chapters in microeconomics. So let's go ahead and get started on this chapter, chapter 4. Okay, so you can open up the chapter 4 study guide and the example file. We'll get to that in a minute. Okay, and then I'm just going to open up the PowerPoint file for chapter 4. Okay, so chapter 4's material is on elasticity, and I'll explain what that means if you haven't heard of this concept. There's a bunch of different types, so let's just start with kind of the general definition. And the first, or the main type, which is price elasticity. Okay, so the first type of elasticity we're going to talk about and probably spend most of the time on, and what's probably most familiar to you, is the price elasticity of demand, or this is just like the general elasticity. So let's introduce this on slides 2 through 3. All right, so elasticity in general measures kind of the responsiveness of one variable to changes in another. And so you see here that this is looking at the first one, or the first elasticity we'll talk about, and I guess, most of the time on, is the price elasticity of demand. And what this does is it measures the responsiveness of demanders or consumers to changes in price. All right, and so you know that the law of demand dictates that when the price goes up, quantity demanded goes the other direction. But this looks at kind of how responsive it is. So it takes it to one step further and looks at the reactiveness or the kind of the percent changes of demand to price changes. All right, so we'll kind of categorize things as more elastic or inelastic. And so elastic means kind of what it sounds like is that quantity demanded is more responsive to price. So when price changes, basically what we're saying is demand responds more than that change in price. And then we'll look at some examples of that and define that more. But then there's the other type. You can also categorize it as inelastic. So that means that the demand is not as responsive as price, and so when price changes for some good or service, the consumers respond, but not as much. And so we'll see what these mean by elastic versus inelastic, but they're very important distinctions because they play a role in like taxes, what firms should do. And so let's first just kind of define mathematically what the price elasticity of demand is. Okay, so this here is the kind of the equation definition, or the kind of in words what the elasticity of demand is. So here this E subscript D is the price elasticity of demand coefficient or notation variable. Okay, and this just measures exactly what it says, the percent change in quantity demanded of some good or service X. And if you divide that by the percent change in price of the product or service, then that's the elasticity, right? So this measures exactly how much demand responds to price changes. So we'll stick with this simple definition, but if you get the percent change over the percent change, that exactly quantifies where this good is in terms of its elasticity. Is it inelastic, elastic, or does it depend? Okay, so the responsiveness of quantity demanded to price, the price elasticity of demand is just calculated like this. So percent change in demand over percent change in price. Okay, and so the reason why we use this metric is because it gives us the capability to make comparisons across different goods and services and their respective demands. Okay, and so you know that like you can look at separate graphs or separate demand graphs where when the price of that good goes up, then demand changes. But what this does is it puts everything in percent and it makes it unit free, and so therefore if something is more elastic to another good, then you can use that in comparison because this eliminates the units, puts everything in percent, and because of that, you can easily make cross-good or cross-service comparisons on how elastic one good is compared to another. Okay, so we need to denote which goods are going to be essentially relatively elastic, and versus which goods, on the other hand, are relatively inelastic. And there's a cutoff for that. And so let's define where the cutoff is for elastic versus inelastic. Alright, so let's look at slides 6 through 8. Alright, so when that coefficient or that calculation comes out, and I think it said here, but you can look at the elasticity in one of two ways. So basically, we normally have because of the law of demand, when price goes up or when price changes, demand goes the opposite direction. So that's always going to give us a negative sign. So you can I usually just leave the negative sign because it doesn't really affect the interpretation, or you can eliminate it, like they say here. So either way, just you can keep the negative sign or eliminate it, but just know how you're interpreting it. So just know that pretty much all of the elasticities, if you don't take away the negative sign, will be negative because of the inverse relationship between price and demand. But either way is fine. Okay, so either when you take the absolute value of the negative elasticity or you just eliminate it entirely, whether that's bigger or less than 1 determines if it's inelastic or elastic. So if the absolute value of your elasticity is bigger than 1, that means it's in the elastic region. So that's just mathematically saying that demand is responding more than price. So if you go back to the equation, okay, so if the top part is bigger than the bottom part in percent-wise, then that has to be bigger than 1. So that has to mean that demand changed more than price in percent terms. So if this is bigger than this, and if the top is bigger than the bottom, you'll get a coefficient that's bigger than 1, meaning the demand is more responsive, and that's elastic. Okay, now if you know, so this is, we'll skip this one for now, but okay, so if it's, on the other hand, if it's less than 1, that means the good is classified as inelastic. And so if you look back at the equation, this should make total sense mathematically. Okay, if the top part is smaller than the bottom part, or the bottom part is bigger than the top part, that means the change in price is bigger. So if demand is less responsive than price, you get a number less than 1, and that means it's more, demand's less responsive, so it's inelastic. Alright, so before we talk about the extreme cases, which are perfectly inelastic and perfectly elastic, let's make sure we fully understand like where goods would go if they're elastic versus inelastic. So it usually helps just to think of some examples, and so let's start with elastic. Okay, so let me make a note here that the elasticity is calculated from different points, and so therefore the elasticity can change. So when you calculate elasticity on a demand curve, you'll get different elasticities along the demand curve. So just know that this so the price elasticity of demand changes along a demand curve. So that means the responsiveness depends on where you are on the demand curve, and this will make sense when you look at the calculations. So there's different regions of the demand curve which are inelastic, and different regions which are inelastic. And so goods that are more elastic, or if you're in the elastic region, you can quantify those. So that's why I like to say that something is relatively elastic, meaning it's mostly elastic, because there's still some parts of the demand curve that are inelastic. But let's stick with elastic or relatively elastic. Okay, so this is the easiest one because most goods are elastic. So most goods, you'll get a bigger response if there's a price change than the price change in general. And so goods that are more responsive than price are very common because most goods you can shop around and you lose customers if you change the price too much. So you can classify most goods, I'd say, as relatively elastic. So like, okay, most of those things, or all those things I listed, food, clothing, cars, shoes, and many others. Now, the reason why those just general categories are elastic is because the customer can shop around, and so if the price goes up for food, you can just buy a different type of food, and the same with clothing and cars and shoes. So when there's lots of options, when you have lots of substitutes, and you can shop around, then if the firm or the company raises the price, you can just buy the cheaper good from some other company. Or if they lower the price, you might buy it because it's now cheaper. So if you have options, usually the good is more elastic. And this normally means that the demand curve is flatter. So you typically have a flatter demand curve for an elastic good. So the demand curve for a relatively elastic good is downward sloping but relatively flat. And so if I had an example, I can show you what I mean here. Yeah, so this is good here. We'll get to the slide, but see how the curve is, it's a demand curve, it's downward sloping, but it's pretty flat. And so that would mean that most of the curve is, in general, is elastic, it's more responsive to price. Whereas if you get a steeper curve, like this next one, okay, that's more inelastic, it's steeper, meaning that consumers don't respond as much to price changes. Okay, so just looking at the picture gives you a good idea of what we're talking about. So more elastic, more inelastic, and that's kind of what we're talking about. So the steepness of the curve really determines the elasticity. Okay, so we know that most goods, assuming there's substitutes, you can shop around, they're more elastic, but it helps to quantify or denote which goods we think are inelastic too. Okay, so the demand curve for a relatively inelastic good is steeper, so this one would definitely be more inelastic. Okay, and this one is a little bit trickier, but it helps to think of some examples for goods that are more inelastic. Okay, so can we think of some examples of some relatively inelastic goods? And that means that when the price changes, the demand changes, but not so much. So, like when the price goes up, you might lose some customers, but most customers still buy the good. So, what are some goods and services which you think you classify as mostly inelastic, meaning that the consumers don't respond much to price changes? So, can you think of some examples of inelastic goods? Yep, gasoline. Yeah, that's definitely correct. What type of water? Okay, that one depends. No, I'd say water bottles. No, because you can. Yeah, your home water service, like the water. So yeah, that's a good one because it depends, and so water bottles no because you can probably shop around. But tap water, like the service to your home, that you can't really shop around for that. You have to pay the water bill, so that would be inelastic. Okay, so gasoline is the most classic example of an inelastic good because so many people drive a car or something that requires gasoline. There's really no substitute for it unless you have an electric car. And so when the price of gasoline goes up or down, you don't see that big of a change in consumer behavior. But these other ones are important too because water bottles, if the price of water bottles goes up too much, then you can just buy something else. You can buy, like you can get like the big jugs delivered. You can buy sparkling water. You can buy something else that's cheaper. There's substitutes for that. But your home water service, like the water bill, that you have to have. If they raise the price, you pretty much have to pay it because it's difficult to live somewhere without the water service. Okay. So yeah, I think that gives us the idea there. So yeah, so we kind of get the idea that most goods go in the elastic type, and then specific goods go in the inelastic, and there's also two extreme cases. Look like this. Okay, let's do let's do the extreme cases. Okay, the extreme cases are defined or classified like this. So if it's perfectly inelastic or perfectly elastic, we'll start with perfectly inelastic. Okay, so here's what the graph would look like. This is the demand curve. Okay, so this is price, this is quantity, and this is your demand curve, which means that the demand is set, and no matter what the price is, you get the same demand. So demand doesn't respond at all to price changes. So no matter what the price is, demand is the same. Now this is an extreme, and most goods or services don't go into this category. But if you can think of some examples of goods that might be have an elasticity of 0, which is a perfectly inelastic demand curve, it helps to understand the concept. Okay, so what might be a perfectly inelastic good or service? Can we think of some extreme examples in which no matter what the price is, all the customers still buy the good or service? Okay, any ideas or any guesses? Yeah, so you're on the right track there. So right, that's the way you want to go for this. And so any kind of okay, so yeah, you're on the right track because any medication that's like absolutely requires an individual or like a life changing or life saving surgery or procedure or like a ventilator or something like that. So any medical procedure or medication or something like that, where the customer's life depends on it, then it's hard to see where um, they wouldn't pay for that good or service. And so if you absolutely have to have it, I mean, these are extreme examples. Those are the things you classify as like perfectly inelastic. Okay, so good. So the other extreme, flip the curve around and you get a perfectly elastic good. And so this means that the opposite of this case, no demand doesn't respond at all. Here, demand responds 100%, or any price change, you lose all the customers. Okay, so this is perfectly elastic. In other words, we have a flat, perfectly horizontal demand curve, and any price other than this, no customer is going to pay it. Okay, so this is another important extreme to think about. So let's see if we can think of an example or examples of perfectly elastic goods. Okay, so can we think of this one's probably the most difficult because it's kind of weird. But can you think of like a type of or just what are we talking about when uh, the demand curve is set at a gaming? Well, gaming consoles, not really because I mean I assume like if you mean like an Xbox.
That's what I was sort of going with, because the more they end up being a lot of people like, oh, that's too much, or like, oh, that's really cheap, let me go buy that kind of thing.
Yeah, so those might be those are definitely elastic because you have options, but I think well I think some people would still buy it at certain higher prices. And so maybe if you really jack up the price, then yeah. But I think some customers would still buy it. Then maybe I'm wrong. So I don't know. I think, but what I'm looking for is sort of kind of a key word. More of the good itself doesn't matter. It's more of how much you can substitute. Okay, so it's actually we'll use that example of gaming consoles just to prove the point here, but you have to. So yes, and luxury. Well, luxury has a weird demand thing, and like some luxury goods, like you'll get customers that pay more if the price goes up. So luxury goods have a weird behavior depending on the customers. Well, high-end cars, I think if you raise the price, you get a higher demand, right? So that's, yeah, so I think you're thinking of it, but you're thinking of it the other way, where, so I'm saying if you raise the price, nobody buys it, but on the other hand, if you raise the price and more people buy it, then you might, uh, then that's a luxury good. That could actually be like a, upward sloping demand curve. Okay, and so, yeah, I think that would be a whole different concept. Okay, yeah, so that's, I mean, you kind of, yeah, you have the idea where the price is set by demand, and it's not going to be lower because the, basically the firms can't operate at that lower price. And so this is the price that is set by demand in kind of a long run cycle. And so what we're saying is that if the price is raised, uh, they won't buy it because they'll just buy the other perfect substitute. So yeah, that's exactly right. And if you think of it, if you go back to the gaming console, I'm going to frame this as the right way. So let's say you have two, let's say there's two types of gaming consoles. Okay, if we were to use that example and say that Xbox and PlayStation are the only two gaming consoles, and they're the exact same, in other words, they're perfect substitutes, then it would work because if they are the same thing, which they're not, but if they were, then the only thing that determines the customer buying it is the price. So if it was the exact same thing, and someone someone tried to sell one of them, like if they're the exact same thing, and someone tries to sell the Xbox for a higher price, everyone's going to buy the PlayStation because it's the exact same thing and the price is lower. Now, in reality, there's different features, but that's the idea. So you have to have okay, so good must be defined as perfect substitutes to have a perfectly elastic demand curve. So I think we get the idea. You guys are giving good examples. And so gaming consoles only if they're exactly the same thing. Luxury goods, they could have a whole different demand structure, so that would be something different. And right, so if you raise the price, it's not that nobody wants it, it's that they buy the cheaper alternative, which is the exact same thing at the lower price. And you won't get a lower price because this is the price that consumers say they're willing to pay. And so no one's going to charge a lower price. Alright, so it's a little confusing, but I think we get the idea. So any questions on how we're categorizing things as elastic, inelastic, and then what goes into the perfectly inelastic and perfectly elastic? So this one I think is the most confusing, but I think we get the idea. Okay, so let's, next thing. Alright, so let's jump real quick to slide 15 to 16, because these are the things that determine what's more elastic versus inelastic. Okay, so these are the determinants of elasticity of demand. In other words, these help determine if it's more responsive than other things. So the first thing should make sense. If the good is more, if there are more substitutes, if there's more substitutability, then it's more elastic because the customers can switch to the other good that is a substitute. So the more substitutes available, the more elastic the good is. Okay, and normally the higher proportion of income the good is, the more elastic you are. And so this is the best way to think of this is like things that would take up a big chunk of your income but are not everyday items like vacations. Okay, so something that would be a high percentage of your income spent. Like if you were to take a big vacation and all of a sudden that vacation got way more expensive, you might cancel it. Or if you're going to buy a new car and you found the car went up in price a lot, you either not buy the car or buy a different car. So things that take up a big portion of your income, like those examples, would be more elastic. Okay, and so your luxury example comes in here because luxury goods are definitely more elastic because you don't have to have them, you can shop around. But it would be hard to classify them as perfectly elastic unless they were perfect substitutes. But luxury goods are definitely highly elastic. And so that was a good example, but more of the super elastic but not perfectly elastic. Okay, so luxury goods are highly elastic but not perfectly elastic unless they are perfect substitutes. So the only way they would work for perfectly elastic is if you had, if you went to like an artisan market and there were like two sellers that sold the same exact luxury necklace or something, then that would be perfectly elastic. But yeah, so does that make sense for the elastic or for the luxury goods analysis? Okay, great. Perfectly elastic would be like pencils. So again, only if the pencils are exactly the same. So like you have to do this like thought example. So, okay, so it does work if you have pencil A and pencil B. And pencil A and pencil B are the exact same identical product, except the price. And so if it's the exact same thing, then the customer just wants the cheaper good. Now, if there's different features, like some fancy eraser or like thicker lead or some like rubber grip, something like that, if there's attributes, then that plays a role. So it doesn't matter what it is, it matters that they're perfect substitutes. Okay. Alright, so where are we at here? So goods that have more substitutes are more elastic. Goods like vacations and new cars that take up a big percentage of your income, more elastic. Luxury goods are more elastic because you don't need them, you can shop around. And then also time, the longer the time period goes on, the more elastic the good becomes. Okay, so this usually gets this idea across. So things are more elastic as time goes on. So if you understand the gasoline example, so gasoline is very inelastic in the short run, but studies have shown that gasoline is much more elastic in the long run, like over months or years. Can we see why that would be the case? Okay, so it's kind of, so like, let's say if you have a car and the price of gasoline goes up, you have to drive to work or whatever in normal times. So if you rely on your car and the price of gasoline goes up, in the short run, you have to pay for it because there's no other way for you to get around. But if the price of gasoline goes up a lot and stays high for a long time, like if the price of gasoline went up to like $10 per gallon, so if gasoline went up to $10 per gallon and stayed that way for a year, what would happen most likely is like tomorrow, a lot of people would still buy it. But if that went on like over a year, if it stayed that way for a year, you'd start to see people on the margin be like, I'm not paying this price, and either switch to other alternatives. So you'd see people start to do things like, hey, all those alternatives, you can make adjustments, usually in the long run, but in the short run, you're pretty stuck. But if the price of gasoline went up that much, you'd see people start to do these other things. But in the short run, there's not much you can do. Okay, and then so this chart's a little outdated because I mean I don't know about, I mean my parents still get the newspaper, but I don't know anybody else who does. So what this price elasticity of demand number or this coefficient means? So the lower the coefficient, like just these numbers are, I don't know how accurate they are anymore, but the purpose is to see what the number is, and the lower it is, the more inelastic it is. So electricity, like household electricity, is very inelastic because you don't have an alternative. The same thing with like cell phone service, cigarettes, medical care, auto repair. So all these things, or most of these things should make sense why they're inelastic. And then once you get to the over one region, you get things like beef. So if beef gets expensive, you can just buy chicken or pork. If restaurant meals get too high, you can cook your own food. You can shop around. And the same with fresh peas. If anyone even buys fresh peas, if the price of fresh peas goes up, you can buy some other vegetables. So if you have more alternatives, you can shop around. Normally, the more elastic that get is, because fuel alternatives like gasoline or electricity, it's more inelastic. Alright, so the next thing is called the total revenue test. Let's look at slides 9 to 11 first. Okay, so we know that simply calculating revenue from one good for a firm is just the price of that good times quantity. So this is like the example we did in chapter 2, where we had the banana bread example, where you got revenue. Okay, so we did that, something similar to that in chapter 2, I think it was. And so this will help us, so the point here is to see the length or the relationship between total revenue per firm and elasticity. So this is an important distinction where if the firm is if you're operating in the inelastic region, okay, then price and total revenue move in the same direction. So that means that if it's inelastic, your customers are less responsive. So therefore, increasing the price would give you more revenue because the customers you lost would be less than what you gain by the people that pay the higher price. Okay, but if you're in the elastic region, then price and total revenue move in opposite directions. So as a firm, if you're in the elastic region, or it's an elastic good, you'd want to lower the price and you gain more customers by the ones that came in and bought the lower price than the revenue you lost. So this will help looking at the demand curves here. Okay, so this is a flatter curve. This is a more elastic curve. So we're trying to see like when the manager changes, when the firm changes the price, what happens to revenue. So look here, if we start at A, so revenue is just the price times quantity. So this, geometry-wise, this times this is the area here. So this is the yellow box is the original revenue, price times quantity, and if you lower the price to 1, this big gray rectangle is the revenue. And so what you can see with this flatter curve is that if you're in the elastic region and you lower the price, the additional revenue you get from the customers that buy at the lower price is higher than what you lost for the customers paying the higher price. So see how the blue gain exceeds the yellow loss? Yeah, so this can be summarized as this. Let me say what I'm saying here. Okay, so I think I said this. So if you're operating in the elastic region of the demand curve, then the firm should lower price to increase revenue. So that's what this picture shows you. So if you're in the elastic region, that means that your customers respond more than the price change, right? So if you can get a bunch more customers paying a lower price, that gives you more revenue than what you had at the higher price. Now the other alternative is this, the inelastic region. Okay, so see how this curve is more steep or steeper, more inelastic. And so we start at point C. We do the same analysis. We lower the price from 4 to 1. Look at how responsive the customers are. So the yellow loss exceeds the blue gain here when lowering the price for the inelastic region. And that's because the customers that you got, so not many customers left anyways. So the customers you got at the lower price did not offset what you lost at the revenue from charging the higher price. So charging the higher price and lowering it here, you lose revenue. So the statement I just made can be said the other direction for inelastic region. Alright, so the first one was if you're operating in the inelastic region of the demand curve, differential lower price to increase revenue, and if you're operating in the inelastic region of the demand curve, the manager should increase price to increase revenue. So see how it moves in the opposite direction? And it all has to do with the responsiveness of the customers. And so not only does it depend on the good or service, it depends on where you currently are on the demand curve. Okay, and if you look at, there's a nice, okay, so this is a really nice graph because it shows you how the elasticity changes from point to point. Okay, so there's always the region that's elastic depends on the steepness of the curve, but there's almost always an elastic region and almost always an inelastic region. Okay, so the upper portion of the demand curve has an elastic region, and the lower portion of the demand curve has an inelastic region. Now, the total distance of those regions depends, but if you go far enough up, you're always going to get to the elastic region, and if you go far enough down, you're always going to get to the inelastic region. And this might seem a little weird, but if you do the analysis, like lower the price up here, and calculate the revenue change, you'll see what I mean, and do the same in the bottom portion. And so the calculus of the elasticity depends on where you are in the demand curve. Okay, so the price elasticity of demand depends on where you currently are on the demand curve. Okay, so depending on if you're in the elastic or the elastic region, that dictates what's going to happen to your total revenue. Okay, so even like this flatter curve, which we said was more elastic, it's still going to have an inelastic region, but like, let's just say like, I don't know if you can see my mouse, but most of the curve, probably, this whole big upper region, maybe all the way to B, is elastic, but the bottom portion still has an inelastic region, and then this steeper curve, most of this curve is inelastic, but the upper portion is still elastic. Okay, so what this picture, this elasticity and total revenue graph, this summarizes what we've been talking about. So basically, if you're in the elastic region, if you charge a higher price, you're going to lose too many customers. And if you're in the inelastic region, your customers are not that responsive here. So increasing price would give you more revenue. So elastic region, to increase revenue, lower price. Inelastic region, to increase revenue, increase price. Okay, so that's the gist of the total revenue test. Any questions on what we did here? Okay, and this we didn't look at this slide, but this slide shows you that if you're calculating the revenue. Okay, so here's some example of movie tickets, which don't exist anymore, but here's tickets demanded, here's price per ticket, and then if you calculate the elasticity, it changes. Okay, so see if it's more elastic, okay, at higher prices. If they lower the price, they get more revenue, but once it flips to inelastic, okay, so here's inelastic is less than 1, and in that region, lowering the price, each additional dollar, you lose revenue. So this shows you exactly what we're talking about, where if the price is in this elastic region, lowering the price will give you more revenue, but once it flips to inelastic, lowering the price more and more, you're losing additional revenue. Okay, and again, this depends on the shape of the curve, where you are, the good or service. But this logic always applies. There's always an upper elastic region where you want to cut the price to increase revenue, and always a lower region that's inelastic where you want to increase the price to get more revenue. Okay, so next thing is we're going to talk a little bit about the price elasticity of supply. So this is how suppliers or firms respond to price changes. Let's look at slides 18 to 20 and then 24. Okay, so this is the same concept. We're looking at responsiveness to price changes, but this time for supply. So this measures the sellers or the firm's responsiveness to price changes. Okay, so if it's more elastic supply, then producers are more responsive. And if it's more inelastic, if it's steeper, and producers are less responsive. So it, again, ties into the steepness of the curve, but we're looking at the supply side here. Okay, and so the calculation is very similar. So you see how the elasticity of supply is just the percent change in quantity of supply divided by the percent change in price. So we're looking at the responsiveness of suppliers to changes in the market price of the good. Okay, so if the elasticity of supply is bigger than 1, that mathematically means that the supply response, the change in supply is bigger. The top part of this equation is bigger. So bigger than 1, this is more responsive, whereas if it's less than 1, it's inelastic, because that means that this percent change is bigger, and the whole number is less than 1, so it's inelastic. So same exact idea. Bigger than 1, elastic, less than 1, inelastic. Okay, so the primary determinant, or the main factor that determines how elastic supply is time. So how much time goes on. So usually the longer the firm has to make changes, the more elastic it is. Yeah, this will make total sense when you think of what the elasticity of supply is. And so I think I have one more slide for supply here, which is 24. Okay, so these categories help us determine how elastic supply is, but let's first make sure we understand why time makes supply more elastic. Okay, so the longer the firm has to adjust, the more elastic supply is. So again, we're looking at how firms change their supply to the market price of the good. So you look at like two extreme examples. Let's say like okay, so if there's like a bookseller, if you go to a farmer's market and they're selling books, and all of a sudden like the price of a certain book goes up and consumers want it more, there's not really much they can do other than sell all the books they have. Now, if Amazon sees that the price of a book has gone up, they'll just triple the amount of books they have right away. So the quicker you can make adjustments, like Amazon can, for books, the more elastic they are. But it's going to take the farmers market seller like a long time to make those adjustments, so they're more inelastic. Okay, and then let's see. So these are some more examples of how you categorize elasticity of supply. So antiques are clearly inelastic because they're already done, they're antiques, you can't get more of them, and so changing the supply is pretty much impossible, because it's impossible to make more of them. Okay, now reproductions, if there's a change in the price of reproductions, you can just make more of them, so that's more elastic for suppliers. And then gold, there's a finite amount of gold, and most of it's been extracted. So if there's a change in the selling price of gold, there's not much the firms can do, and that's a more inelastic. So you can see how the easier it is for the firm to make adjustments to prices, the more elastic. But if it's difficult to reproduce the product, like antiques or gold, it's much more inelastic. Okay, so any questions on the supply analysis of the price elasticity of supply and how this works? Yes. All right, next, couple more types of elasticity that we need to look at. So slide 25, let's look at the income elasticity of demand. Okay, so this measures the responsiveness of buyers to changes in income. And so we remember in last chapter for supply and demand, we talked about normal goods and inferior goods. So normal goods, when you get more income, you buy more of it, and inferior goods are the opposite direction. Okay, and this type of elasticity, the income elasticity, would help quantify the responsiveness. So if there's a change in income, basically how much do consumers respond to that change in income? And so this metric is pretty important for sellers of different goods and services because they can look at time, like if there's like tax return season. Okay, so things are all weird this year, but normally tax return season, or not March, April. Okay, so normally this year aside, the tax return time is around April 15th, and so you expect people to get their tax returns around that time, which essentially means that they get a boost in income. And so if sellers of like, I don't know, some kind of good or service knows that they're going to get a jump in demand, they can plan accordingly. And the same for around like December when there used to be Christmas bonuses and things like that. If there's more income coming in through bonuses, then the sellers of those goods and services that have a high income elasticity would pay attention because they're going to get more customers due to the change in income. Okay, the final type of elasticity we'll talk about here, there's many other ones, but slide 27, let's look at the cross elasticity of demand. Okay, and this one is a measure of the responsiveness of sales to changes in the price of another good. So this ties back in from last chapter to the substitutes and complements. Okay, so remember substitutes, the customer can choose between one or the other, depending on the price, and complements, you consume them together. And so therefore that would dictate the sign of this cross elasticity. Okay, so the percent change in quantity demanded of product X divided by the percent change in price of the other good Y. That's how you calculate the price, the cross elasticity of demand. Okay, and again, the size of this, or the calculation would help firms when they see how customers behave. And so if we're looking at substitutes, okay, that's supposed to say versus, but if you're looking at Coke and Pepsi, which are probably clearly substitutes, and if you're looking at the decisions made by both firms, so like the managers of Pepsi and the managers of Coke, if they know that when their price changes, the demand for the other good goes up a lot, or vice versa, that's going to help them determine, should they put the good on sale, should they not, and so on. So knowing this sign or this calculation is very important for managers of substitute companies. Okay, it's also important for the complement side as well. So like if we assume that milk and cereal are complements, like the consumers consume them together in a bundle, then how the consumers react when the price of one of the goods changes is important for the other firm, right? So if the sellers of cereal know how much customers respond when the price of milk goes up or down, that's very important for their business to know what to do, and the same for vice versa. So knowing this calculation if you're in the substitute or complement business and other firms that are related to your good or service is very important. Okay, so I think that's all the key concepts that I had that I wanted to highlight for chapter 4. And so obviously we spent the most amount of time on the price elasticity of demand and the different types of curves and the total revenue tests. So I'd say the most important key concepts are the first three. Okay, so the price elasticity of demand, how you categorize different elasticity ranges, inelastic, elastic, perfectly elastic, and so on. And then how what region of the demand curve determines what happens with total revenue. That's important too. Okay, and so yeah, and then there's more types of elasticity, but I think we've gone through enough. Okay, so questions on any of that material before we look at some examples? All right, so there's some videos you can look at when you get some time. There's one on the elasticity of demand, some more information on that. That's a nice video. This one explains the total revenue tax a little more. And this is on the cost elasticity of demand, some extensions of that. So those are all pretty short, like 5 minutes or 10, less than 10 minutes. Take a look at those when you get a chance. Okay, let's look at some examples. So number one, what are the major determinants of price elasticity of demand? So remember that one slide had those. So the determinants we learned about were substitutability, right? More substitutes, more elastic. Percentage of income, so if it's like a vacation or a new car, more elastic. Luxuries are more elastic than necessities. And the longer the time period goes on, the more consumers can invest. So more time, the good becomes more elastic. Okay, let's use these determinants in our own reasoning to determine or try to figure out which of these goods are relatively elastic and which are more relatively inelastic. Okay, so we talked about this one. Bottled water is relatively elastic because there's lots of other ways you can drink your water. There's lots of other bottled beverages or canned beverages you can buy. So there's lots of substitutes for bottled water, so that's elastic. Okay, toothpaste in general is very inelastic, and that's because there aren't a lot of substitutes for toothpaste. And so just the broad category of toothpaste, inelastic, because there's not a lot of substitutes for it. Okay, but when you break it down to a specific type of toothpaste, like Crest toothpaste, that's elastic because if the price of Crest toothpaste goes up too much, you can just buy some other type of toothpaste. Okay, this one you probably wouldn't know off the top of your head, and neither did I, but ketchup is actually very inelastic. And so apparently there's not a lot of substitutes for ketchup, or maybe there are, but when overall the price of ketchup goes up, you still get most customers buying it. So that's what the research shows. So the broad category of ketchup, inelastic. And diamond bracelets, that's a luxury item, and you can buy different luxury items if this price goes up. So most luxuries are relatively elastic. Last one, F. Microsoft Windows operating system. So that is actually inelastic because there's a huge portion of customers that use that. So most universities, most colleges, most businesses, it's a little bit cheaper than using a Mac. And so because of the number of people that use Windows, it's become a very inelastic good, and there are some substitutes, like Mac, but there's not very many, and because of so many people using Windows, they're going to stay using it. Okay, so number 2 is on the total revenue graph. So how would the following changes in price affect total revenue? So just make a statement if total revenue would go up or down or not change at all. And again, if you look at that graph, this one, okay, this will help you picture what's going on here. So in this region, lowering price increases revenue. In this region, increasing price increases revenue, and then the opposite is true as well. So that's what we're talking about here. Alright, so if price falls and demand is inelastic, okay, what happens to total revenue? So if we're in the inelastic region, that means that consumers don't respond as much. And so if you drop price, that's going to decrease revenue, right? Because you didn't lose that many customers, or you didn't, the customers weren't that responsive, and the revenue you lost at the higher price wasn't compensated for the new customers at the lower price. Okay, so we're saying we were in this region, inelastic, and instead we lowered the price. That's going to decrease total revenue. What if price rises and demand is elastic? So again, look at the picture. We're in the elastic region. Okay, if the firm increases the price, that's the wrong move. That's going to lower revenue. So if we're in that region and we increase the price, total revenue decreases. Okay, C, price rises and supply is elastic. Okay, the next two are kind of a trick, but if price goes up, it doesn't matter what the elasticity of the supply curve is. If the price goes up, revenue for the firm goes up, no matter what. So price goes up, supply is whatever, revenue goes up. So total revenue goes up, and then if price rises and supply is inelastic, that doesn't matter either. They still got a higher price, so total revenue goes up. E, price rises and demand is inelastic. Okay, so look back at the graph. Alright, we're in an inelastic region. Customers are less responsive, so that means they're increasing the price to gain revenue. Okay, so that's an increase in total revenue. And then F, price falls and demand is elastic. Okay, that's the final portion, or the final thing in the graph. Okay, we're up here. We lower the price, and we get more customers. We get more revenue by the additional customers paying the lower price. So total revenue increases. Okay, and then G, price falls and demand is of unit elasticity. And we didn't talk about this one much, but that just means that the elasticity is exactly 1, which means the change in price is exactly the same as the change in demand. So it's a one-to-one. Therefore, if it's the same, total revenue doesn't change because what you gain is offset by what you lost. Okay, so everyone good on the total revenue test and what we talked about here? So this is just restating what we learned about what the elasticity is and how that relates to total revenue. Okay, so now the last couple we'll do some calculations of actually calculating elasticity. So number 3, because of a legal settlement over state healthcare claims in 1999, the U.S. tobacco companies had to raise the average price of a pack of cigarettes from $1.95 to $2.45. I'm sure they're much more than that now. But with this stated, the decline in cigarette sales was estimated at 8%. Okay, what does that imply for the elasticity of demand per cigarette? Okay, so let's use this information in the word problem to calculate the elasticity of demand for cigarettes. Okay, so the elasticity of demand is, we know, the percent change in quantity demanded divided by the percent change in price, right? We know that. Okay, and if you're going from one point to another, you can calculate the percent change as just the change over the original. So you can use this simple formula for all these calculations. So like Q1 is the new quantity and Q0 is the initial quantity. Okay, so we're saying that when the quantity changes from one quantity to another, so what's the change? What's the percent change? That's just the difference. Q1 minus Q0 over the original. So that's how you so the percent change in quantity demanded is exactly this portion here. Q1 minus Q0 over Q0. Okay, and the portion for price, the percent change in price is exactly this portion. Okay, so if Q0 is the initial price, the original price, and the price changes, then the difference over the original is exactly the percent change. So you can use this simple formula to get the percent change over the percent change, where this part is exactly the percent change in quantity demanded, and then this part is exactly the percent change in price. Okay, so hopefully that makes sense. Keep a reference to this formula because you're going to use it on the homework and some other calculations. But does that make sense of how this formula or equation represents the percent change over the percent change. Okay, so for this question, we were given the change of demand, right? So it said the decline in cigarette sales was 8%. So we don't have to calculate that part. We know the percent change in demand is negative 8%. Okay, so just put that there. But we do need to calculate the change in price based on the price going up and what the change is. So here's the price information. Okay, so the price goes up from 195 to 245 per pack. And so that means the old price T0 is 195, the new price T1 is 245, right? And so just plug those into the equation, and we've almost got our elasticity calculation. So go back down here. Percent change in demand was given negative 8%, negative 0.08 in percent or decimal terms. And then T1 is 245, the new price, minus T0 is 195, the old price, divided by the old price of 195. So the change over the original case is simplified. This is still negative 0.08. This is 0.26. And this whole calculation comes out to roughly negative 0.31. So that's our elasticity. That's our price elasticity of demand for cigarettes here. Okay, and that number in absolute value is much less than 1. So that means that customers didn't respond very much to the price change. So that means that elasticity of demand for cigarettes in this example is inelastic. Okay, so you use this formula to get the elasticity. This is the elasticity, and either basically is the absolute value of that bigger than or bigger than or less than 1. So if it's, see how it's 0.31, so that's less than 1, less responsive, that's inelastic. If it were bigger than 1, it would be elastic. Okay, so let me know if there's any questions on that concept. We're going to use the formula again to get the elasticity of demand for this other example, question 4. All right, let's suppose we have price and quantity data for gasoline here. There's just 2 points, that's all we need. So it's point A, the price of gasoline is $100, and quantity demanded is 100 barrels, and then when the price goes up, when it goes to point B, price goes up to 150, the demand is now 90 barrels. Okay, so part A for this example, this one, number 4, you have a homework question very similar to this one, so make sure if you have any questions on this one, then let me know, because this is a homework question, or one just like it. So A, when with the price of Y on the price on the Y-axis and quantity on the X-axis, plot points A and B, and then draw a simple demand curve. So all you're doing here is plot the 2 points and see what the demand curve between the 2 points looks like, just the steepness of it. Here is the price of gasoline. Here's the quantity of gasoline, and I just put the 2 points and drew a line. Here's point A, 100 and 100, and here's B, 90 and 150. So you're welcome just to do this on a piece of paper with a ruler. It might be easier. If you want to do it in Excel, you can look at my example. Right. The example chapter 4 Excel file just has that one sheet like this. Okay, so all I did here is put the 2 points in a chart and then just do a graph in Excel. Alright, so it's easy to do this in Excel, or you're welcome just to draw it on a piece of paper with a ruler, or graphing paper, whatever's easier, but all you have to do is just plot the 2 points, draw a line and label the axes. Okay, so then part B, what is the price elasticity of gasoline? When the price of gasoline rises from 100 to 150, what is the price elasticity of demand for gasoline? So we're calculating the specific responsiveness of demand to the price change here. So use the same formula. Okay, you want the percent change in demand over the percent change in price. We know that's the elasticity, but if you use the same formula where you get the change over the original for demand, so Q1 minus Q0 over Q0, that's the demand portion, the percent change in demand. And then the bottom portion, this is the percent change in price, P1 minus P0 over P0. Okay, next step, just plug in the numbers. So basically Q1 is the newer quantity. So the quantity went from 100 to 90, right? So the initial quantity is 100, the new quantity is 90. So 90 minus 100 over 100. So Q1 is 90. That's the new quantity after the price change. The initial quantity was 100 divided by 100. So the change over the original would give us the percent change in quantity demanded. And then do the same for the price. The price went up from 100 to 150, right? So how do we get the percent change in price? Just do the change over the original, which means the new price is 150. The old price was 100 divided by the old price of 100. So for price, the change over the original is this. So this same formula, and plug in your numbers, and if you do this, put this in a calculator or solve this, it comes out to, I think, exactly negative 0.2. Okay, so the price elasticity of demand for gasoline here is negative 0.2. It's also fine if you just say 0.2. It doesn't matter to me, but I usually keep the negative because it represents a lot of demand, but either negative 0.2 or 0.2, either one is fine. And then part C, would you classify this here as relatively elastic or relatively inelastic? So obviously, if you take the absolute value of negative 0.2, that is much less than 1, showing that demand didn't respond as much as the price change, so demand was less responsive. The coefficient of 0.2 is less than 1, so that's going to be relatively inelastic. Okay, so questions on this one, number 4, because there's a homework question very similar to this. So everyone good on this, what we did here? Okay, I think that's the last example here. Okay, let me just show you the homework for chapter 4. Okay, so just one question here. This shouldn't take you too long, but just make sure you understand how to do the elasticity calculation and how to categorize that as inelastic or elastic. So here's another example for your homework. So you got data points, point A and point B for price and quantity for kale. So here's the initial price and quantity, point A. So then the price goes up, and that's the quantity demanded. So same thing, just plot the points for it, part A. Then use that general formula to calculate the elasticity. And then when you get that, just state that it's, check if it's bigger than or less than 1 in absolute value, and that'll tell you if it's inelastic or elastic. Okay, so if there's any questions on that chapter 4 homework, let me know. It shouldn't be too tough, but that's it, just that one problem. And so the chapter 4 homework is due in the discussion forum for chapter 4. Okay, so that goes there. That's due by next week. That's due by next Wednesday sometime. For chapter 4 homework. And this, again, most of you have done it, but there's still a couple of students that need to do the first 3 homeworks. So chapter 1 homework, chapter 2 homework, and chapter 3 homework. Those are all technically due today. So if you haven't got those turned in, try to get those in by today. And probably later this week or this weekend, I'll get some grades up for your homeworks and post my solutions. So make sure if you haven't done the homeworks for 1, 2, and 3, those are due today, and try to get those in. Okay, and then next time. Okay, the next time we're going to do chapter 5, which is on public goods and externalities. We have one more homework before the take-home midterm, and then I think the next meeting. Okay, so this is today. This is next week. We'll do chapter 5. And then week 5 meeting, I think we'll do it. I'll try to prepare like a practice exam or some practice problems for the take home, and we'll do a little review for the take home midterm. Okay, so we'll finish chapters 1 through 5 next week. That'll be chapter 5. Then we'll kind of pause, and I'll give you guys a take home exam on stuff from chapters 1 through 5, and we'll spend the week 5 that is doing a review. Won't be any new material, but make sure you come that day because that'll be like the review session for the exam. Okay, so I think that's all I have for tonight. I'll see everyone next Wednesday at the same time. And everyone stay safe, and thanks for joining, and everyone have a good week. Thank you.